Okay, we continue. So what happens? So this was the initial state, right? The omega 1 E1 and omega 2 E2 was the initial state, and this was the sum over system of the whole system together, omega 0 E1 E2. And now you allow the system to achieve an equilibrium. So what happens, or how can we modify this equation on achieving an equilibrium? On equilibrium, I can always assume that this the left hand side, the omega 0 E1 E2, is having a minimum value, right? Because that is one thing which you want to achieve. So I can write it as dou of omega 0 E1 E2 divided by dou E1 is equal to dou of omega 1 E1 divided by dou E1 into omega 2 E2, right? I'm just differentiating, partial differentiation in terms of E1. So dou of omega 0 E1 E2 divided by dou of E1 is equal to dou of omega 1 E1 divided by dou E1 into omega 2 E2. So this, we are just differentiating the equation number the 1 plus omega 1 E1 into dou of omega 2 divided by dou E2 into dou E2 divided by dou E1. Don't get confused. But actually it should be like this, right? Dou of omega 1 E1 by dou E1 into dou omega 2 E2 plus omega 1 E1 into dou of omega 2 E2 divided by dou E1. But what we did was that we applied the peculiarity of the partial differentiations, where, right, dou of omega 2 E2 E1 is equal to dou of omega 2 E2 into dou of E2 by E1. So I just supplied this thing to here. So that's what I did. Okay, so now how can we simplify this one, right? I call this as equation number 2. So what will be, if I apply over here, I know that dou of dou E2 by dou E1 is equal to minus 1, and dou E1 divided by dou E2 is equal to minus 1. Why? Because my dou E0 by dou E1 or whatever it is going to be 0. So therefore, since this is a constant, right, because E1 plus E2 is a constant, therefore dou E2 by dou E1 is equal to minus 1, and dou E1 by dou E2 is equal to minus 1. Therefore we substitute that into the equation 3 which is this equation. So this will be 0 because that is that's a peak value, right? So therefore, left hand side is 0, and dou omega 1 E1 divided by dou E1 omega 2 E2 minus omega 1 E1 into dou of omega 2 E2 divided by dou E2. So that was the quantity, right? So this is 0 in the left hand side, and you have two quantities in the right hand side, and this can be simplified as 1 by omega 1 E1 into dou of omega 1 E1 divided by dou E1 is equal to 1 by omega 2 E2 into dou of omega 2 E2 divided by dou E2. So we have the left hand side 0 and we have the two expressions. So I take one of these to the left hand side. I can write then it as 1 by omega 1 E1 into dou of omega 1 E1 divided by dou E1 is equal to 1 by omega 2 E2 into dou of omega 2 by dou E2. So you can see a similarity in the left hand sides and the right hand side, right? So if I consider one of them, I can write it as dou of ln omega 1 E1 divided by dou E1 is equal to dou of ln omega 2 E2 divided by dou E2. So they can be considered to be equivalents. Of course, E1 is equal to E1 bar and E2 is equal to E2 bar. Now we define a quantity beta. It's a new quantity which we introduce. Beta is equal to dou of ln omega NVE divided by dou E. So if that is the case, then I can write I write this as equation 4, okay? So I can write the equation 4 as beta 1 is equal to beta 2. And this is the condition for equilibrium, where in the system where the temperature is allowed to transfer till an energy is achieved, a particular energy is achieved, but it does not allow the transfer of number of particles or the wall does not move. So in that conditions, the beta 1 is equal to beta 2. So we have much more to discuss in this. We still have not made the connection between the thermodynamics and the statistics, but let's go slow in the beginning. So we will continue in the next class. Okay. So we will make the real relation between the thermodynamics and the statistical quantity in the next class. Thank you.